NEC, let's hear what you have to say.
Great. Thank you all very much for coming today. We're going to introduce our new product line. It's a networking product line called Programmable Flow. It is the first generally available OpenFlow-based fabric. So we're going to have a lot of great discussion today about what's going on in OpenFlow, how NEC is participating both in the ecosystem and in how we're using OpenFlow in our products now and going forward. I want to start a little bit about NEC because I think get that to go. NEC may be relatively unknown in many of the communities that the pack pushers participate in. And then we'll dive into the product introduction. From there, we'll talk about what we're doing in OpenFlow and move on to the programmable flow architecture and use cases. And from there, we have an extensive demo that we have planned for you. First, just a couple slides on NEC. You may not know NEC, but it's a $37 billion diversified IT company. We do invest $3 billion in research last year. So we had significant investments in networking overall and in OpenFlow. And we're a global presence. So this is a global business. As we talked about yesterday, we have an interest in platform network and compute. And we have a large IT services practice. So we are very interested in tying together IT and networking and solving some of the problems that our customers face in getting these systems to work. Here in the US, we have a nationwide presence. Our headquarters is actually in Irving, Texas, but we have offices across much of the US serving customers in sales and product areas. We cover a variety of product solution areas. So NEC has a very large practice in networking services and solutions design for NEC customers today. And so this networking product fits into a new capability that allows customers a broader choice of the networking solutions that they can choose from. In terms of cloud infrastructure from NEC, we offer a full line of cloud infrastructure from servers, storage, software, and now adding the networking component. And so we'll talk about how the networking component fits in today. Would love to have you back to talk more about some of the other products as well. Our customer list includes a variety of customers from our major verticals, including universities, the government, hospitality, and healthcare. These are our major focuses, and then our broader solutions practice for the service providers at the top. So yesterday we talked briefly about what we're doing in OpenFlow. Today we want to introduce the product line. Programmable Flow product line was introduced back in May at Interop, where we were the first to bring OpenFlow to the market as a GA-supported product. As we talked about, NEC's been involved in OpenFlow from the very early start, participating in the work being done at Stanford and launching a first generation of switches in 23 research institutions, including Stanford, Georgia Tech, Rutgers, and so forth. Based on that experience, we rolled out this product line in May. The initial product line includes the Programmable Flow controller, which is a OpenFlow-based controller, and a Programmable Flow family of switches that started with a 1G switch that we'll talk about next. In terms,
I'm curious how many of our guests are familiar with Programmable Flow already.
probably not. Right?
We all attended the OpenFlow Switch yesterday.
Yes.
Right.
Technology
So
or
that was
product?
all you heard, though, right? Are you familiar with?
Technology or product?
Product. Yeah. Okay, so we'll start with the product, and then we'll dive deeper into the technology. Okay. So the controller is OpenFlow 1.0 supporting, so it supports the 1.0 standard. We're tracking closely the standard development. There will be multiple issues coming forward, as discussed yesterday. It is a Linux hardware appliance, so we sell it as an appliance, but it is running on standard Intel processor, and it is a enterprise class product. So it is not an open source project from Stanford. It is enterprise class ready to go into a data center. And we have a fully redundant solution with automated failover. So customers, this is sort of a minimum requirement for customers to begin deploy OpenFlow in production. Some of the benefits of OpenFlow controller include ability to build multi-tenant networks, that is to run multiple networks on the same physical hardware. The ability to create location-free networks, that is, that VM mobility is unrestricted by subnets, so that we can manage networks independent of where the VMs exist and where the network appliances exist. We can build any topology. So because OpenFlow does not require a spanning tree, we no longer care about building trees and avoiding loops. We can scale the network out in that case rather than scale it up. Waypoint routing is our term for being able to change the direction of network traffic based on policy. So we can put if-then statements in the network that allow us to redirect traffic.
So are you saying that because your controller controls like N switches, and the next question will be what N is,
Yes.
You don't need spanning tree in that part of the bridging domain anymore?
In the OpenFlow domain, we no
Yeah.
longer need it.
Okay. I think some people will love that.
So especially for customers that want a lot of resiliency, this removes a lot of headaches in LAN environments. And then because OpenFlow gives us this ability to measure the packets going through the network, we can aggregate that view into an end-to-end performance monitoring and troubleshooting. So unlike SFlow, which is a sample, this is a census and can provide us end-to-end views rather than having multiple pieces that we have to stitch together. And then OpenFlow network control is, we think today, this is enterprise class. That is, provides the topology discovery, the fault detection, the self-repair that's part of the OpenFlow standard today.
Or when you say topology discovery, that's not part of the OpenFlow standard. So you have to do whatever you have to do to discover the topology.
Yes.
So what are you doing?
You want to take that?
Okay, so yesterday there was a discussion for the discovery issue, but so we are using an LLDP protocol to discover. Yeah.
So you're actually sending LLDPs out with packet out, listening who gets packet in,
Yep.
and then figure out how they're tied together.
Sure.
Thank you.
This is a program flow management console. On the right, you can see the physical view into the network. And on the left, you can see the virtual networks that we've built in this particular physical topology. So we'll spend more time in the demo in the console so we can see what's going on in the network. A couple things to see here, though, is here we've built a mesh, so we don't have to worry about any particular topology. And we have 4 switches connecting 6 VMs, and we can see the route that a flow is taking.
So are these layer 2 or layer 3 networks?
So with OpenFlow, we no longer have to care what type of network it is. So
No, when you create a virtual network for the customer,
yes.
is that thing a layer 2 domain like VLAN, or do you actually do routing within the customer's virtual network and split it in different subnets?
So we can do both. So the example that you see here, we've connected two subnets via virtual router. We'll demonstrate this in a few minutes. So the virtual router has a policy that connects the two subnets, and then we have a policy that says any streaming port traffic send to the streaming server, otherwise send to the firewall and on to the rest of the devices.
And the virtual firewall is actually not a VM, I guess. It's just an abstraction.
It's an abstraction. It could be a VM.
Yeah, but it could be an abstraction that you program then into the individual switches.
It's a target. Yeah.
So are you doing that now, or are you using VM today?
So it can be an IP address on the network, and we're doing that today. Did I answer your question?
Yeah. Next, when you mentioned that there are VMs connected to the switch, VMs are, are you saying that's a virtual switch?
In this example, this is not a virtual switch. So so we have three different port mapping types.
Okay.
Can be based on port, can be based on MAC, and can be based on VLAN.
Okay.
Or
so that's
combination.
Not a physical switch.
Yes.
Okay.
Yeah. So in this case, because we don't have we didn't deploy a vSwitch, we've physically mapped this VM to the physical network,
So
to the
with
port.
VMware environment, you are limited to this because you can't get in there.
Very perceptive. Yes.
For Zen environment, can you get in there?
Yes.
Wow, good.
So with the VMware environment, we're using the VMware API to pull port groups to create the virtual networks that are associated with those port groups.
So you actually communicate with vCenter.
Yes.
Cool.
As one option.
Okay, I like it.
So that'll dynamically allow you to dynamically move virtual machines and
Yeah.
reconfigure the network.
That'll be the demo. Yes.
That's awesome. You're like the third company now that has that. That's of the entire networking industry. So that's pretty cool.
Yeah. Our customers see it as a lot of value.
Absolutely.
So our first switch we introduced back in May is a 48 port 1G plus 4 port 10G switch. This is our second generation OpenFlow Switch, and we focused on the stability and capability of OpenFlow in this switch. We've added flow entry capacity so that we can support 64,000 fully expanded flow table entries or 160,000 of the more limited flow entries. This is a fully hybrid OpenFlow switch, so it can run both layer 2, layer 3 protocols and OpenFlow on the same switch, allowing us to connect between legacy networks and the OpenFlow networks.
So you can run in hybrid mode.
Yes.
Now, when you say, I would need to check what OpenFlow 1.0 really does. Does it have any wildcard?
Yes.
Yes. Yeah.
Sure.
Okay, so when you say 64,000 entries there, they don't have to be host routes. They could actually be, they have to be host routes. Right?
Yeah, you can use a wildcard for any part of the 12 tuple.
Yeah, but you can't use mask anymore, can you?
Yeah, we do.
Okay, so actually these aren't host routes, these are actual IP routes with prefix.
It can be IP routing. It can be a layer 2 switching.
Yeah.
Yeah. Then it's a multi-layer switching.
Cool.
Marvin's happy.
Yes.
You're doing good so far.
I'm worried, I'm way too happy.
So am I. So we can provide you a data sheet providing the full list of features, but it has standard layer 2, 3 features. And it's data center ready with fully redundant hot swappable parts and front to back or back to front airflow and SFP ports. So that was a brief introduction of products. I'd like to talk a little bit about what we're doing in the OpenFlow space and then get into some of the architectures you can build with this. Okay, cool. Any questions? Okay, Yunso?
Hi, so my name is Soo-Hoon Yeon. I'm a senior manager in the business development in OpenFlow programmer for this project. Then I would like to introduce our ecosystem activity today. Then, as you may know, that the Open Networking Foundation has established March this year. Then we have six board members, and then today 41 adapters member of the ONF. Then NEC is one of the founding member from the beginning. Then we have so far. So you may know that NEC is only one GA commercial supplier today. Then so we are actively talking with all these partners to have our ecosystems. And then one of the events in this June, we have an Interop in Las Vegas. And then these vendors presented their prototypes, and then we provided interoperability at the event as an Interop. Then also last week, we have an Open Networking Summit in Stanford Universities. Then many vendors also, up to 20 groups presented their OpenFlow-based demonstration. Then NEC also provided interoperability demo with IBM switches and Brocade switches. And then these switches also NEC switches. So these three vendor switches are controlled by the NEC's OpenFlow controller. Then you already know that, may already know that IBM just announced they are having the OpenFlow capability to their switches. So we are actively trying to have some interoperability with any other OpenFlow switches. Then in that event, FT Orange also use our switches, and then also Radware use our OpenFlow-based, open source-based controllers. Then ESNet use our switches, Stanford also. So many groups are using our product for their demonstrations, right? Then, and not only the such switch vendor, we are also actively talking with network appliance vendors to integrate with our programmable flow and then load balancer or security appliances. Maybe that we can show some part of that demo too. Then today we are not able to disclose such vendors, partners name directly, but yeah, we hope to announce pretty soon that. Then, especially today, I would like to introduce our partnership with Microsoft. In September, there was an MS Build event was in Anaheim. Then Microsoft announced the Windows 8. Then as a part of the Windows 8, Server 8, they have extensible vSwitch programs, which allow the third party to provide value-added vSwitch capability to the Windows 8 servers. Then NEC successfully demonstrated the OpenFlow extension to the OpenFlow for Hyper-V demo. Then we also announced that NEC is going to provide a commercial product of the virtual switch, OpenFlow-based virtual switch for Windows 8 servers. Then we hope to provide our such vSwitch at the same time as the Windows 8 servers release sometime next year. Right. Then not only the OpenFlow community, but we are also, NEC is going to expand our OpenFlow capability to other communities. Then one example is an OpenStack. In early October, we had there was an OpenStack conference. Then we proposed the NEC Quantum plugin. So in OpenStack world, Nova manages the server platform. Then Quantum provides a networking control or network virtualization control. Then we provided the NEC plugin to interoperable with and talk to these OpenFlow-based programmer flow. Then our controller has a Northbound API which talk to the Quantum plugin. Then in programmer flow world, we can provide them virtualized network and then virtual tenancies. Then we show them the prototype demo then, and then also we are going to provide this NEC plugin for the open source. Okay. All right, and that's my slide. Any questions?
It's cool.
Thank you. Right. So, right.
Actually, your OpenFlow controller is just the basic that you need to control the switches.
Yeah.
And then you have your own applications on top of that.
Right.
That's what I'm going to talk about.
Ah,
Sure.